Hi guys, you are welcome to another video. So in this video we are going to be looking at conversion of units. Conversion of units. So actually conversion of units is something that is very important in all the STEM field. In all the STEM field, that is science, technology, engineering and mathematics. So you deal with different conversions. So knowing how to convert accurately and conveniently, it's very important. So we are going to be looking at a method in this video that can be used for any type of conversion. All right. So the first thing we are going to look at prefaces. There's what we call prefaces. So when you talk about conversion in the SI units, so there are different types of units. We have the SI and the American system. So, but basically the SI, that's the metric system. The metric system is actually the most convenient and the easiest. So we are going to look at the metric system in this video. The metric system. The metric system. All right. So under the metric system, we have what we call the prefaces, and the different prefaces we have. We have the micro. Micro simply means 10 raised power minus 6. That is the 1 millionth. Then we have the milli. Then that is 10 raised power minus 3. So that is a thousandth. Then we have what we call the centi. Centi is 10 raised power minus 2. That is hundredth. Then we have the deci. Then we have the deci. That is 10 raised power minus 1. That is a tenth. So all you need to remember when you are talking about your conversion in the metric system are just these four. You have others. That is, you also have kilo, the ones that are greater than 10 or greater than 1. We have kilo. Kilo simply means 10 raised power 3. So we have giga, mega, and so on and so forth. So once you can remember your prefaces, you don't really have any problem in conversion. So, and this is the way you go about it. When you talk about, when you have 1 centimeter now, centimeter, then let's use the symbol. So 1 centimeter is simply equal to, this is just 1, that is centi is 1 divided by 10 raised power 2, so which is meter. So we are simply replacing the whole of this with the centi. So centi means 1 divided by 10 raised power 2. So by the time you do your cross multiplication, it's going to be 1 10 raised power 2 centimeter is equal to 1 meter. So that is 100 centimeter is equal to 1 meter. So when you have something like, let's say 1 millimeter, so is equal to 1 divided by 110,000. So milli means thousand meter. So and this will give you 1000 millimeter is equal to 1 meter. So when you have 1 kilometer, this is equal to, kilo is 1000, 10 is power 3 meter. So you can see that is all you need to remember. Just remember your prefaces, and you are not going to have any problem in whatsoever conversion at all that you are dealing with. So once you can remember your prefaces accurately. Alright, let's go straight into some conversions now. We are going to look at different conversions in different quantities. So let's look at this. Let's just pick some random numbers. Let's say we are given 2.15 kilogram per let's say centimeter per centimeter. So this is per centimeter per second. So this is a unit of this is absolute viscosity. So but that is not important as far as this video is concerned. We are only concerned with the unit. So but by the way, it is a unit for absolute viscosity of fluid. Alright, if you have to convert this to, let's say you have to convert to gram per meter per minute. So This is just a random question. So this is what you do. The question you are given, which is this, the one you are converting, you are going to draw a table. You are going to draw a table. It's not a it's just a simple table. So at the left extreme end, you are going to put your value, which is equal to 2.15 kilogram. Then you have a vertical line, so divided by centimeter. You put your centimeter. So centimeter, then you have your second. So of course, this means the centimeter and the seconds, they are in the denominator. So this will be equal to, so in order to convert to a gram per meter per minute now. So that is, you are converting the kilogram to gram, you are converting the centimeter to meter, and you are converting the seconds to minutes. So you deal with them one at a time. So let's start with the kilogram to gram. So you remember your conversion factors. So that is, you write 1 kilogram at the denominator here. The reason why we are writing 1 kilogram, so that the kilogram can cancel the kilogram up, can cancel the kilogram down, is equal to 1000 gram. So we leave that. So that at the end of the day, this will cancel this. So which means you are having gram now. Then you've succeeded in converting the kilogram. Then you go to the centimeter to meter now. So you write your 1 centimeter here, or you can write 100 centimeter is equal to 1 meter. So the centimeter here will cancel the centimeter here. So you are done with kilogram and centimeter. You are done with these two now. These two are gone. So you are left with seconds. So that is the time. So you have 60 seconds. Make how many minutes? 1 minute. So that's the seconds as counted the second. So that means that you are done with all the units. So that means you converted all the units. So meaning that you only left with gram per meter per minute. So what you just simply need to do here is to multiply the numbers. You multiply the numbers. You multiply the numbers. That is, let me draw the line again. So what you simply need to do here is just, you have 215. That's one more example. There is 60 missing here. That's times 60. So let's press our calculator. So by pressing the calculator, this will be 2.15 times 1000 times 1000 times 100 times 60. So, and that is equal to, let's write it in standard form. That is 1.29 times 10 raised to the power of 1, 2, 3, 4, 5, 6. So that is equal to 6 gram. So remember, this is minutes. This is minutes. So this gram per meter per minute. So that is that. Alright, let's look at another example under this quantities in physical calculations. So let's look at this. Let's say let's look at this quantity. Let's say we are given 201. Yeah, let's say we have centimeter square per minute. So this is, I think, kinematic viscosity. So let's say we have to convert it to meter square per second. Meter square per second. You still do the same thing. You draw your line. So that is going to be 201 centimeter square. Then you have minutes. So you start with the centimeter, then later you go to the minutes. So how many centimeter? You are converting centimeter to meter. So how many centimeter makes 1 meter? So that's going to be 100 centimeter. Because the reason why you are writing it down so that the centimeter can cancel is equals to 1 meter. So, but remember in this case, you are dealing with centimeter square, then you have to put your square here. You square both the number and the units. Remember both the number and the units. So that at the end of the day, when you expand this bracket, this centimeter square will cancel. So that this will cancel this. But remember, this square is also for the 100. So maybe you shouldn't cancel it yet. Or you can even decide not to cancel it at all. But you have it at the back of your mind that the denominator will cancel the numerator. So then, how many seconds make 1 minute? So you have 1 minute is equal to 60 seconds, so that the minute will cancel the minute. So at the end of the day, your answer is going to be 201 meter square divided by, so that's good, sorry, the second missing here, divided by, so this centimeter, remember, is gone. So this is going to be 100 square because of this square here. So times 60. So by pressing your calculator, that is 201 divided by 100 square divided by 60. So you put your seconds here. So that is going to be equal to, that is 3.35 times 10 raised to power minus 4 meter square per second. So that is all you need to do in your conversion. So let's look at a last example very quickly. Let's say we are given, let's look at acceleration. So acceleration is meter per second square. Let's say we are given 4 meter, or let's say we are converting from a lower unit to a higher unit. So let's say we are 4 centimeter per second square, or let's say per minute square in this case, per minute square. So we have to convert it to meter per second square. That is acceleration. So you draw your line, you draw your table. So that is 4 centimeter. Then you have your meter square, the denominator, minute square, minute square. So minute square. So this is good. So let's get rid of the centimeter to meter first. So that's 100 centimeter is equal to 1 meter. So let's draw the vertical line. They want to convert the minutes to seconds. So that is 1 minute. That is equal to 60 seconds. But remember, you are dealing with a square here. So that means you have to square the minutes here. You have to square everything. You're going to be square. And you square this also. So that the minute square will cancel the minute square. So this will give you 4. The centimeter here has cancelled this. So 4 times 1 meter. So the minutes has cancelled also. Just cancel it here. So that's 4 times 1 meter divided by 100 times 60 square seconds square. So that will be equal to, so let's press the calculator. So pressing the calculator, 4 divided by 100 divided by 60 square. So that is 1.11, that is meter, 1.11 times 10 raised power times 10 raised power of minus 5 meter per second square, or meter per second, anyway you want to write it, per second square. So you can see with this method, conversion, it's very simple and convenient. So let's look at some conversions of concentration. That let's say you are given sodium hydroxide in a solution. You know, remember sodium hydroxide is an alkaline. So let's say the concentration of this is, let's say we have 2 mole per dmq to, we have to convert it in gram per centimeter cube. So all you need to remember here is that you don't need to write the compound if you like. So but I will advise you write it. So this is going to be, so you have sodium hydroxide, then you have 2 mole divided by dmq. So you don't need to put the minus again once it's going down. So you draw your line. Okay, so let's start. Remember, you are converting the mole to gram and the dmq to cmq. So let's start with the mole. So before we can get our mole, we need to get the how many what's the molar mass of sodium hydroxide. So the sodium hydroxide has to be 3 plus 16. So 3 plus 16, that's going to be 39. Yes, 39 plus that is 40. So this is 40 gram. So we are going to write 1 mole is equal to 40 gram. So you draw a line so that this mole will cancel the mole. Then we go to the dmq. So you convert dmq to cmq. So we are going to say, let's start with the centimeter to decimeter before looking at the centimeter cube and decimeter cube. So how many decimeter or how many centimeter make 1 decimeter? So we have 10 centimeter make 1 decimeter. So then you cube it, your cube. So by doing it this way now, so you can simply just multiply the numbers. So this is going to be 2. So this decimeter cube will cancel this decimeter cube. So this will now give you 2 times 40 gram divided by 1000, that's 10 by 3, 1000 centimeter cube. So this will give you 80 divided by 1000. 80 divided by 1000, and that will give you 0.08 gram per centimeter cube. So that is that. Okay, let's look at the reverse situation now. Let's convert from gram per dmq to mole per dmq. So let's look at something like calcium carbonate. So let's look at calcium carbonate. So calcium carbonate. So this calcium carbonate. So let's say we have 0.8 gram per dmq to mole. Okay, let's call this mole per let's say cm cube. So you are going to find the molar mass of calcium carbonate. The molar mass of calcium carbonate, that is 40 plus 12, 40 plus 12, then plus, that's 16 times, plus 16 times 3. So that is 100. So this is going to be 100. So you have 100 gram. That is the molar mass of calcium carbonate. So 100, that is 40 plus 12, 40 plus 12 plus 16 times 3. Alright, so 100 gram. So you draw your line. So you put your 0.8 gram dmq. So how many? Then let's start with the gram. So we want to convert the gram to mole. So that will be equal to, so we have 100 gram of calcium carbonate which is equal to 1 mole. So then let's convert this DMQ to CMQ. So you know that 1 DMQ, 1 decimeter is equal to 10 centimeter. Then we put the cube, so that at the end of the day, this will cancel this. Decimeter cube will cancel decimeter cube, so that this will give us 0.8 times 1 mole divided by 1000 centimeter cube, and that will be equal to 8 times 10 raised to power minus 4 mole per dm cube per centimeter cube. That is equal to 8 times 10 raised to power minus 4 mole per centimeter cube. Alright, so that is that. So with this method of conversion, you don't need to struggle with conversion in your calculation. Conversion should be done conveniently. So I would like you to subscribe to this channel and watch out for more interesting videos. So thank you.